Okay, in this video, I'll show you guys how to integrate 1 over x to the 6th power plus 1. But this time, we are not going to do the traditional partial fractions to break this down because we did already last time. It took us over 1 hour. If you haven't seen a video, you can go check that out later on after you finish watch this video. Right here, I will show you how to break this down in the following way. We still have to work with fractions, but check this out. And to make this challenging for us, we will be doing a lot of algebras in our heads. So follow along, right? First, I will be factoring out the denominator, and to do that, this is the same as x to the 2nd power, and then you cube that plus 1 cube. So you can factor the sum of 2 cubes, right? In the real world, of course. So when you do that, you get x squared plus 1. And then that's the first factor. The second factor is x squared, which is x to the 4th power minus x squared times 1, which is x squared, and then plus 1 squared, which is still 1. And then you have that dx. And don't forget, you still have the 1 on the top. 1 always likes to be on the top. Okay, so that's nice. Now, for the denominator, we see that we have an x squared plus 1. And ask that question, wouldn't it be nice? Wouldn't it be nice if we have x squared plus 1 on the top as well? Yes, it would. So let's make that happen. Let me just go ahead and add x squared plus 1, like this. The 1 was positive, so I'll put on plus sign. But this and that, they are no longer the same. It's okay, because we can minus x squared, and now they are still the same, right? And then we'll be pairing up these two over that denominator, and then this over that denominator. So we can split the fractions. So here we go. The first integral will be, when you do this over that, the x squared plus 1 cancel. So you just have 1 over this. So let me just put down 1 over x to the 4th power minus x squared plus 1. And let me close this integral right here. And then you see this right here, it's a minus. So of course, let's put on the minus. And that's the integral. And we have x squared on the top. But don't be sad. Yes, I know, even though you cannot cancel out anything, seriously, don't be sad. Why? Because if you look back, this denominator is, of course, still x to the 6th power plus 1. And if you look at x to the 6th power as x to the 3rd power and then square, good things happens, right? So let me put that down. X to the 3rd power square plus 1 dx. And yes, this right here, we can just finish it by doing a little u sub, letting u equal to x to the 3rd power. Now, this is the monster, but it's okay because we can still break it down in the following way. Alright, so hopefully you guys have seen a video of mine that showed you how to integrate 1 over x to the 4th power plus 1, right, without this middle term. That video, and this integral right here, they are really similar. What we want is, I want to have x squared right here to help me out. Yes, even though we have the x squared earlier, but let me use it again right here. Just pretend that this is the only integral that you're working out right now, alright? So here we go. I will be putting down the x squared right here, and of course that was a plus 1, so let me just write it down like this. And of course, we will have to minus x squared right away, like that. Okay, but unfortunately this time, the denominator is x to the 4th power minus x squared plus 1. We cannot cancel anything, no matter how you pair it, right? So, in fact, I will actually have more terms to work with. I want to have this over that to work with. And right here, I actually want to have a 1 to work with as well. Well, check this out. Imagine if I just put down minus 1 right here, what will happen? Yes, I will just kill the whole integral. That's no good. So in fact, I will have to put down plus 1, then that will be much better. And this is a much better way to put down plus 1. Let me just put down parentheses right here, right? So you can see that we are going to do this over that denominator and then minus this over this denominator, all right? Well. On the top, x squared minus x squared, that's gone, good. 1 minus negative 1 is 2. Originally, we only have that 1, right? So what can we do? Well, don't minus 1 anymore because you'll go crazy. Let me just multiply by 1/2. It's much easier. Constant multiple of an integral, doesn't hurt. If you put on minus 1 right here, oh, that would be so bad. So that will be what we'll be looking at, right? So let's go ahead and finish this. Right, actually, I have to continue right here. This is 1/2, of course. And as I said, this over that denominator. So that's the integral. And in the meantime, I will actually divide everything by x squared. And we get 1 plus 1 over x squared right here first. Over this right here becomes x squared minus 1 plus 1 over x squared. And then let's put on the dx, close that. Next, we have a minus and then that 1/2. So let's put on a minus here. And then the 1/2, and then the integral, this over that, and again, we'll divide everything by x squared. So we end up with 1 minus 1 over x squared over everything becomes x squared minus 1 plus 1 over x squared dx. And yes, right here you can finish this integral already, but I don't feel like doing any integral yet. So let me just write it down right again. X squared over x cubed squared plus 1 dx, right? Now let's just focus on this too. Well, if you look at the denominator here, we can almost factor it. It's almost factorable right here as well. Well, in order for us to factor it, we actually want to have a 2 right here, so we can factor. Likewise, we actually want to have a minus 2 right here instead, right? It's okay, because what we can do is look at this and say that's x squared minus 2 and then plus 1 over x squared. This right here is factorable, so nice. But don't forget, original, this is a minus 1. So what we have to do is, yes, just put plus 1 after that. Nice, right? So you will see this right here, it's going to be the 1/2 integral 1 plus 1 over x squared. This is so good because once you factor this, you get x minus 1 over x and then square and then plus 1. Close the integral. And if you let u equal to this right here, the derivative of x minus 1 over x is precisely 1 plus 1 over x squared. And yes, it's pretty much it for the integral. Now, look at this. We have that minus 1/2. I'll just put everything in black right here, actually, just 1/2, like that. Unfortunately, I cannot do the same thing right here because we have 1 minus 1 over x squared, right? So in order for me to produce similar thing right here, I want to have x plus 1 over x and then square. So I can let the inside be the u and then we can get at the top, right? Well, instead of putting down minus 2 right here like that, we want to have plus 2 instead. So look at this right here. I will write it down as x squared plus 2 and then of course the plus 1 over x squared. In order to preserve the minus 1, we will have to minus 3 right here. Still the same, still cool, right? So you see this is the integral 1 minus 1 over x squared over this right here becomes x plus 1 over x, and then you square that. And then let's look at the minus 3s, square root of 3 square, and of course that's a minus in between, and then we have the dx right here. And then perhaps let me just write this down one more time, the integral of this. Yeah, and we are ready to integrate. Let's do everything in our head first. Right here, let u equal to x minus 1 over x, and then the root of that is precisely this. So you get 1 over u squared plus 1. So you get the inverse tangent of u for that integral, right? And then don't forget you have that 1/2 right here. So the first one is 1/2 times the inverse tangent of the inside, which is x minus 1 over x, like this. Done. Next, let u equal to this, you'll get du for that, right? But this time it's 1 over u squared minus square root of 3 squared. Two things. Right here it's minus. You can use the inverse hyperbolic tangent. And yes, inverse hyperbolic tangent or inverse hyperbolic cotangent, it depends on the value that you're integrating, okay? The interval that you're integrating. If you just want to have an answer, let's just use the inverse hyperbolic tangent, right? You can check out more detail on when you should use the inverse hyperbolic tangent or the inverse hyperbolic cotangent for my other video. But you have this square root of 3 that bother you, right? So let me write down the formula for you guys. Right here, I'll just put this down. Note, right? Integral 1 over u squared minus a squared du, right? This doesn't look like integral sign. Let me write it down better. This right here, as I said, either the hyperbolic cotangent, inverse hyperbolic cotangent or inverse hyperbolic tangent is okay, because you don't have the numbers here. It's okay. All right. Usually a goes first, but this time it's u goes first, right? U squared. So you actually have a minus, and then you have the inverse hyperbolic tangent of u, and you have to divide it by a. And then in fact, if you do some substitution, you also have to divide it by the a on the outside, like this, right? So that's the idea. I'm not going to put on plus c because this is the main dish. So we have the minus 1/2. This is my a. Goes down here, so we have the square root of 3. But you see, originally, this was a minus. I should put on the minus in black first. When you do this right here, you end up with another minus. So minus minus becomes plus, like this. And you end up with the inverse hyperbolic, let me put on inverse hyperbolic tangent of 1 over a first, if you would like. So you can put on 1 over square root of 3 right here, if you would like. And then multiply by the u, which is that. So you can write it down as parentheses, x plus 1 over x, close that, and you're done for that. Lastly, for this part, let u equal to this, and do this in your head, so you get a minus. And you actually have a 1/3 factor because the derivative of x to the third power is 3x squared, so you have the 1/3 factor, so don't forget that. So we have the 1/3 inverse tangent, right, of x to the third power. And you are all done. So that's very nice, very nice. And of course, in the end, put down the plus c, right? Box the answer right here. Whew. Yeah, this is it. Yeah. Hopefully you guys all like this video. Leave a comment down below and let me know if you guys like the traditional partial fractions more or this kind of algebra more. And yeah, if you guys are new to my channel, be sure to subscribe. Thank you guys so much, and as always, that's it.